All right, folks, this is Larry Maslino. I'm here in Module 3, and the topic here is solving an equation with several occurrences of a variable. Now, notice this equation is kind of messy because it has fractions. Let me write the equation. Now, one thing I'm going to do here is notice there's a negative sign in front of this first fraction. I'm going to move that negative sign and associate it with the top number, the numerator. So I'm going to put the negative sign up on top like this. It's just going to make it easier to work with this fraction a little later. So here's the equation they're giving us. All right, well, I'm noticing that, of course, we want to solve for v, right? That's the instruction, solve for v. That really means get v by itself on one side of the equation. All right, well, I want to get rid of fractions. That's important because these fractions are making the equation more complicated than it needs to be. So step one here is going to be get rid of fractions. All right, to do that, there's two steps. One is look at the denominators and find what's called the least common denominator. So let's do that. I'm going to look at the denominators. I'm seeing a 3, a 5, and a 3. Well, the least common denominator is some number here such that both 3 and 5 evenly divide into this number. So I'm looking for a number. Usually it's going to be bigger than the numbers I'm starting with. Well, the number 15 would work, right? Because 3 and 5 both evenly divide into 15. All right, so let me go to step 2. Step 2 says multiply both sides by this 15, by this LCD. So multiply both sides of the equation by the LCD 15. Now here's where I got to be careful because I have to really multiply every expression on left side and right side by 15. So I'm going to put parentheses around every one of these expressions here. And I'm going to be multiplying every one of these 4 expressions by the number 15. So I'm going to put a 15 here, 15 here. Notice I'm multiplying every expression by 15. Now, the reason for doing this is now the denominators are going to get canceled. So let me come here to this first fraction. Well, I'm noticing it's a 15 on top and a 3 on the bottom. So I'm going to think of this as 15 divided by 3. Well, 15 divided by 3 is 5. I'm going to copy down that negative 7v. That's just going to come with me. Let me come to the next fraction. I'm noticing I have a 15 on top and a 5 on the bottom. Well, that's 15 divided by 5. That's 3. And I'm going to bring down this blue 7 with me. And now let me go over to the right-hand side of the equation. Well, on the right-hand side, again, I have a 15 on top and a 3 on the bottom. 15 divided by 3, that's 5. Bring down that 2v with me. And in the back here, I just have a 15 times 2. That's 30. Notice the fractions have gone away, which is excellent, because now this equation is going to be a lot easier to work with. So let me go ahead and multiply this out. 5 times negative 7 here, that's negative 35v. 3 times 7 is 21. On this side, I have 5 times 2v, that's 10v. Subtract 30. All right, what I want to do now is get the v's to one side of the equation and get the numbers over to the other side. Now, it's up to me. I could either get the v's to the left side or get the v's over to the right side. Doesn't matter. We'll get the same answer, whatever you think is easier. Well, I'm noticing here's a negative 35v. To cancel that out, I'm going to add 35v to both sides. And you might be saying, well, why didn't you subtract 10v from both sides? You could do that also. That's equally correct. But I'm going to add 35v to both sides. Here, negative 35v, positive 35v cancels out. That leaves me just a negative 21 here. On this side, I have 10v and 35v. That's 45v. Subtract 30. So we just got the v's to one side. Good. We now have to get the numbers over to the other side. So I want to add 30 to both sides now. That'll cancel out the subtraction 30. So that cancels. On the left side, we have negative 21 plus 30. I think that's a positive 9. And that's equal to 45v. Well, last step to get v by itself, because v is being multiplied by 45, I want to get rid of that multiplication. I'm going to divide both sides by 45. 45 on top cancels out the 45 on the bottom. I'm being left with v equals, I'm going to write it over here. We're left at v equals 9 over 45. Now, I'm not done yet because I'm noticing Alex says simplify your answer. And I'm noticing that I'm noticing 9 can evenly divide into both top and bottom. So I'm going to divide the top by 9 and the bottom by 9. This is one way to simplify fractions. On the top, 9 divided by 9 is 1. On the bottom, 45 divided by 9 is 5. So here's my answer, 1 over 5. Okay, so the key to this was let's get rid of fractions from this equation as the first step. To do that, find the LCD, multiply both sides of the equation by the LCD. That gets rid of fractions, and then you have a simpler equation to solve if the fractions have disappeared. Okay, I hope this is helpful as you're working in this topic.